Within this video, we're going to look at drawing condensed structures in organic chemistry. So the first thing you need to know before we get into drawing these structures is these four elements here: carbon, nitrogen, oxygen, and fluorine. Now, the valence of carbon is 4 here. The valence of nitrogen is 5. The valence of oxygen is 6, and the valence of fluorine is 7. And these are the valencies. And what this means is how many valence or outer electrons there are. So this is important because we know carbon has 4 outer electrons. To reach its noble gas configuration of 8 electrons in its outer shell, it needs to bond up to 4 more times. So carbon likes to bond up to 4 times. So we can see for nitrogen to reach its 8 electron outer shells, we should know that nitrogen likes to bond up to 3 times. Hence, oxygen 6, 8 by 6. So it likes to form 2, and fluorine 1. And these are bonds formed by the elements, what they like to form. And obviously this trend is seen down the group, so down the halogens, you can see that chlorine, bromine, iodine, and so forth will actually all like to form one bond to form a noble gas configuration, complete that OS step. Now oxygen, we can see that sulfur, selenium, etc., they all form 2 extra bonds, and hence carbon, nitrogen, down their groups, they also form 2 bonds, so 3 bonds and 4 bonds. So the general structure of a carbon atom should look something like this. In this example, we're going to use bonding with hydrogen, so carbons should look like this, sort of a tetrahedral shape here. Nitrogen will have 3 bonds, it's 3 bonds here, and we'll also have a valent, a lone pair of electrons right here, and that's just because it has 8 electrons, bear in mind, in its outer shell. And here, each bond represents 2 electrons, by the way, so 1, 2, 3, 4, 5, 6, 7, 8. And oxygen here, we know oxygen is formed 2 bonds, but also oxygen likes to form a double bonds as well. But we'll get into that in a little bit. So here we can see oxygen bonded to the hydrogen. We have it. We can see it's 2 bonds here, and oxygen actually has 2 lone pairs, like this in this bent structure here. And then we have fluorine with hydrogen, fluorine. Obviously, now we're going to have our 1, 2, 3, 4, 5, 6 here, 1 up, and there we go. So what I first want to talk about is how do you go from displayed formula. So we've seen displayed formula like this before. Let me just draw ethane here for you. How might we be able to draw this in a structural formula? You might already know what structural formula is, so please be my guest and go ahead and draw this down already. But what this would look like in structural formula would be CH3, CH3, just like this right here. You might sometimes see structural formula actually with a bond between them as well. but here today I'm just going to do it without the bond here. And that is ethane as much as this is ethane here. So that's pretty simple, huh? So I'm going to give you maybe 5 seconds right now to just draw this propane displayed formula here in condensed structural formula, just like I've done with ethane. See if you guys can do that. So in the structural formula, this propane should look something like this: CH3, CH2, CH3, like this here. Now, say we have a methyl group here instead. We have a methyl group. So we have 2-methyl propane, 2-methyl propane. How might we draw this in structural formula, do you think? Just going to give you a clue. Use brackets. Going to give you 2 seconds here just to sort of try and draw this down. So this should look something like this: CH3, CH, bracket CH3, CH3. Now what these brackets actually mean is just what's bonded onto that middle carbon here. So I'm going to show you another example where you might use brackets, and we're just going to use propane again, but except this time we are going to use propan-2-ol. Sorry about that. Propan-2-ol. We've got an alcohol here, and just like I've shown you up here before with these brackets, we're actually going to show the hydroxyl group, the OH group, in brackets here. So we've got CH3, then we've got our CH, and then in brackets here I'm just going to draw OH molecule, and then finish off with our CH3. And now this is the complete structural formula for propan-2-ol. Okay, so we know how to draw this. What if I say we have some sort of longer alkane, and I'm not going to draw in the hydrogens here, but just want you to know that at the end of every single covalent bond here, there is a hydrogen. How might we draw this in structural formula? This is displayed. This is 1, 2, 3, 4, 5, 6. This is hexane here. How might we draw hexane in structural formula? Well, there's a simpler way than just drawing out all the CH3s, CH2, CH2, and what have you. We can use another bracket to condense it. So here we have 4 CH2s all in a row. We can just write it like this. Now it's hexane. Bearing in mind they have to be next to each other like this. They can't just be, say you can't, for either end of these carbons, you can't have CH3 2 and then the CH2 4. You can't have this. It doesn't work like that. So now we've seen that. How about if I give you a structural formula? CH3, C, H, CH3, CH2, CH3. How about you guys try and draw them in displayed formula? So this is structural or condensed formula. Condensed. Now, you guys try and draw it in displayed formula. So you should have 1, 2. These are your main carbons, 4. And we should have 1 methyl group here. As the displayed formula. Now what if you're just given, I'm just going to give you the names of a couple organic compounds here, and I want you to draw out the structural formula for each of them. So I want hexane 2-ol. I want I want 1 chloropropane, and I also want just butene right here. So go ahead and draw those structural formula. Pause the video here. So for the first one, hexane 2-ol, we should easily be able to draw its display formula. But how about drawing its structural formula? We have seen hexane here already, but what about this alcohol version? Well, it's not too much different. Not too different. CH, and this is on the 2-ol. So I'm going to draw in red here our oxygen group. And we know we're also going to have 3 of those, and ending with a CH3. So we can see we have a 1, 2, 3, 4, 5, 6 main carbons, and we have our oxygen group here. Now what about chloropropane? Well, we're going to have our first, it's on the first carbon, right? So we're going to have our CH2, then we're going to have our chlorine. You can draw it in, when it comes to chlorine, you can draw it like this, or you can draw it in the brackets, it doesn't matter. When you have a halogen like this, and then we can draw our CH2, CH3. And for our skipping another there, for our third, we have butene, which I have not showed you guys how to do yet, so if you haven't done it, not to worry. I didn't specify butene, sorry. I just said butene, so I'm going to assume it's on the double bond is on the first carbon. So we're going to have a CH2, and we actually put in the double bond here, CH, and this is only a CH here because we can see this carbon is already bonded to 4 things, 1, 2 bonds, 3 bonds, and 4 bonds. And here we're going to end our structural formula with a CH. Now another thing we need to look at here is drawing cyclo, sort of alicyclic, it's a better word for molecules, using structural formula. So, say for example we have cyclobutane here, and we want to draw this in structural formula. How might we go about this? Well, this is actually quite simple. We have to keep the square bonds in the middle, we have to keep the square bonds in the middle. However, we just condense the two hydrogen bonds to each carbon. So we simply go CH2, 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 just like this. Now, what about cyclohexane? What about cyclohexane? Just pause the video here if you want to give that a go. But here, I'm just first going to draw out my cyclohexane in structural formula, and it should look something like this. I did make it a little bit wonky. There we go, it looks a little bit better. So you can see here we've still got our hexagon shape with 6 bonds. However, it's just the carbon hydrogen that have been condensed, like this. So what if someone asked you to draw structural formula to skeletal formula and vice versa? We looked at skeletal formula last video, so let's see if you guys can do this. First, I'm just gonna give you a simple condensed structure here of butane. See if you guys can draw this and put that into skeletal form. I won't tell you guys the name next time, it's just to make it a little bit easier. But here we go. So here we have our 4 carbon skeleton. 1, 2, 3, 4 carbons, and as you remember, none of the atoms are shown in skeletal formula. It's the simplest form to draw, just to draw organic compounds. So I'm going to give you another one here. CH3, CH, CH3, CH2, CH3. So if you guys can draw the skeletal formula of that, and also name this molecule here. So if we count our carbons, 1, 2, 3, 4, we know it's going to be bute something, but we know there's also a methyl group here, so we can tell it's going to be, and the methyl group is on carbon 2, so we can tell it's going to be 2 methyl butane. Now, let's go ahead and draw the skeletal formula. Here's our 4 carbon base, just as above, but on the second carbon, we are drawing our methyl. We have our 1, 2, 3, 4, and then our 5th carbon here. So let's go ahead and draw one of these with a functional group in them. Let's use 2 functional groups. Why not? 2 Cl. So we've got a chlorine here. We've got a CH, and we got a CH3. Then we got a in the brackets here. We got a CH2, 3, and then we have got a CH2OH. Now this is a bit more complicated, so if you're having trouble naming this, don't worry as much. But if you guys could draw the skeletal formula for that, that would be great. So the first thing we want to look for here is 1, 2, 3, 4, 5, 6 carbon atoms. So we know it's going to be hex something. Now, as we can see here, there's 1 chlorine. So we're going to have 1 chloro hex something. Now, I'm just rubbing out the hex to make some room. There's a methyl group here on carbon 2. So we're going to have a 2 methyl 2 chloro, 2 methyl, hex, and now the halogens always come before the methyls. It's all in alphabetical order and in carbon number order. Well, alphabetical order takes priority, and here we've got an alcohol in the last one, hexan, and we can just write hexanol here. We don't have to specify which one because we already have the chloro on the one. And so let's draw our 6 carbon skeleton, and on the one here we're going to draw our chlorine, then on the 2 our methyl, and then on the last one our OH, our hydroxyl group, to make 1 chloro, 2 methyl, hexanol. And so the last part of this video, I just want to look at drawing alkenes in structural formula. So let's take pentene, pent-2-ene, for example, which is drawn as 1, 2, 3, like so. Putting the hydrogens here. And whilst I'm putting the hydrogens, just go ahead and try and draw this in structural formula. So first you're going to want to start off with your 5 carbon base. 1, 2, 3, 4, 5. Sorry, let me draw that a little bit bigger so we can fit in everything. 1, 2, 3, 4, 5. And from your carbon 2, we need this double bond here. So we're just going to go ahead and draw a double bond in like so. And I've just realised I've drawn skeletal formula. But there you go, that's how you draw it in skeletal formula. So in structural formula, we are going to want to draw it as this. First our CH3, then our CH bonded to another CH, because we know they've made up 4 bonds. There's no CH2. That would be 5 bonds and that would be incorrect. And now we have our next CH2 and then our CH3 like so. So just last off, can you guys draw for me hex, can you guys draw for me 1 fluoro, hex 2-ene, just in condensed formula for me. Just in condensed formula. So you should first of all get your CH2 starting off, because you have your 1 fluoro here taking up one of the bonds of chlorine. So our F here, just going to draw it in red so you guys can see it perfectly. And F. Then we're going to have our CH here, because it's bonded to another CH. Double bonded. This double bond right here. Now this we should then have the rest of our organic compound here. So we use 1, 2, 3. So we're going to have another CH2. So we can just do CH2, 2, and CH3. So we've got our 1 carbon, 2 carbon, 3 carbon, 4, 5 carbon, and our 6 carbon here. Just one quick last thing I want to show you guys is how would you draw this? How would you draw this molecule in structural form? So we've seen before that carbon bonds 4 times because it has 4 valence, 4 bonds. So how might you draw this? Well, in displayed formula, sorry. well. And these two carbons are bonded. We can see that this carbon has its one bond here, and this carbon has its one bond here, but both are missing 3 bonds. So these in fact bond 3 times with each other, each bond being worth for 2 electrons. So this 3 bonds here is actually worth 6 electrons, and thus each has made up their bond. So that's it for this video. I hope you guys enjoyed, and you now know how to draw condensed structural formulas.